Good morning. Good morning, students. Okay. So now, with respect to the last class, anyone can type the word on which concept we have discussed? Yes, good morning. Good morning to everyone. Can any one of you can type what and all we have discussed in the last class? Okay, molar mass, very good. Yes, right? So we had discussed about mole and then we had discussed about molar mass, right? Now when it comes to the mole, what do you mean by mole? Yes, average atomic mass, very good. We will come to that, right? Very good. So even then we have discussed about average atomic mass. Yes, average atomic mass, right? And we had some more discussion on atomic mass unit, AMU, right? We had discussed about atomic mass unit. Anyway, so when I am talking about atomic mass unit, it is the mass or it's a value which will be equals to 1 by 12th of the carbon 12 atom. It will be equal to the mass of 1 by 12th of the carbon 12 isotope. So that is atomic mass unit, right? So whenever we are writing atomic mass unit for an element, that means we are dealing with the single element. That's what we have understood. If I am telling hydrogen as one atomic mass unit, that means I am talking about one hydrogen atom. Fine? So that's what we have discussed. Now when it comes to the mole, when I am talking about the mole is a number, right? It's a number which equals to the Avogadro's number, which equals to the Avogadro's number. Please remember, many students they will do the mistake. If in the examination if they have asked what is a mole or what are moles, define mole or define moles. So during that time some of the students they will write it as 6.022 into 10 to the power of 23. If you write only that number, you are not going to get the marks, right? So yes, Stephen has written, even Ullas. So that is nothing but it is the number. It is the number of substance which will be equals to the number of carbon 12 atoms which are present in 12 grams of carbon. Both of you are right? So when I am talking about mole, it is the number. It is the number of substance about which we are going to discuss or about which we are discussing. So that can be anything. So mole is the number of substance or elements which will be equals to the number of carbon 12 atoms which are present in 12 gram of carbon 12 atom. Right? So that's where we have the mole. Okay? So that number is nothing but 6.022 into 10 to the power of 23 numbers. But that is not definition of mole. No, we have to define. From where we got this number, we have to define. So that number is nothing but number of carbon 12 atoms which will be there in 12 gram of that particular element. Fine? So all of you have understood? So this number you should remember. Fine? So next one, molar mass. Now when I am talking about the molar mass, normally or it will be expressed in terms of grams. So molar mass is nothing but mass of the 1 mole of substance. which will be expressed in terms of grams. Got my point, all of you? Fine. So when I am talking about molar mass, it is the mass of 1 mole of substance, which will be expressed in terms of grams. That's where we have the molar mass. See, for example, when I am talking about atomic mass unit, for hydrogen atom, it is nearly 1 atomic mass unit. Right? That means we are talking about 1 hydrogen atom. But when I am talking about molar mass, same hydrogen will be written as 1 gram. 1 gram. That is, yes, Rohan, you are right. Which will be expressed in terms of grams. Yes. So when I am talking about same hydrogen, if I want to express in terms of molar mass, now I will be expressing 1 gram. Now very important point here is, it's not 1 hydrogen atom. It is the Avogadro's number of hydrogen atom, which will have the 1 gram. So that's where we have the molar mass. Got my point? It's applicable for anything. I have taken the example of hydrogen. Fine. Now, when it comes to average atomic mass, that's where we are going to consider the atomic mass. We are going to consider the atomic mass plus percent occurrence in the nature, plus in the sense multiplied, percent occurrence in the nature. If there is a presence of isotopes, that's where it is applicable. If we don't have any isotope for an element, then it is not applicable. But when I am talking about average atomic mass, when I am talking about the nature, almost most of the elements they are having isotopes. So therefore, average atomic mass is applicable for almost all the elements. It's applicable for almost all the elements. Only few elements it will not have the isotopes. So fine. So that's where average atomic mass of carbon 12 is 12.011, approximately 12.011, because we have 3 isotopes of carbon and their percent occurrence in the nature is also variable. So therefore it will be having 12.011 as the average atomic mass. Fine. So with respect to your exam point of view, for that is where atomic mass unit very important, significant figures very important, mole very important, molar mass very important with respect to your exam point of view among the whatever concept I have done. Okay? Sir, hagadre beredella important alva? May not be for your exam, but to understand the chemistry as a subject, they are also important. Fine? So that's where we have the yesterday's this one discussion. Fine? So now, today we are going to talk about calculation of molar mass for a given compound. Calculation of molar mass of a given compound. That's what we are going to discuss now. Okay? Now, when I am talking about this particular concept, very important point here is you should know atomic mass. We should know atomic mass of elements present in that compound. Atomic mass of element present in the compound, in the given compound. I will mention it as in the given compound. So that one we should know. Otherwise, we cannot. Fine? So what I mean to tell here is, any compound we can find the molar mass, no doubt. So for that we should know what is that atomic mass of those elements present in that compound. Now the problem here is how to know which are those elements present in a given compound. So for that we should know molecular formula. We should know molecular formula of a given compound. If you don't know the molecular formula, we cannot find number of which are those elements present, then we cannot calculate the molar mass. Got my point? So that's where we have the atomic mass and molecular formula. Now when I am talking about molecular formula, anyway, we are going to discuss all these things in detail in the next concept, that is empirical formula and molecular formula. Fine? So when I am talking about molecular formula, because we know what to mean by atomic mass, right? We know what to mean by compound. Now we have to calculate not only for compound, even for molecule. Compound or molecule. We have to calculate. Fine? So now, when I am talking about molecular formula, so that's what earlier we had not come across. Say for example, if I take the example, someone will tell, calculate the molar mass for sodium hydroxide. Calculate the molar mass for sodium hydroxide. Okay. So in terms of words they have given, not the formula. So first we should write the formula. Sodium symbol is Na. Then hydroxide. So hydroxide is nothing but OH minus. Hydroxide ion. Got my point? So hydroxide. No, Yagnesh, I will come to that. Whatever we have written is sodium bicarbonate. Yes, now we are right. It is NaOH. Got my point? Now, I will make it very clear. As a sodium hydroxide, it is neutral. No charge. No positive charge, no negative charge. Fine? It is neutral. Now, when I am talking about hydroxide, I told it is OH minus. And sodium has the capacity to attain Na plus. So therefore, whenever we are writing the formula, we have to cross multiply. Minus means there is minus 1. Plus means there is plus 1. So 1 here and this one here. So therefore, it can be written as NaOH. Okay. So I have left the gap only because to be below sodium I have written Na. Below hydroxide I have written OH. Otherwise it should be written together. So that's where I have the sodium hydroxide. Now we have another molecule which is called as calcium hydroxide. We have another molecule which is called as calcium hydroxide. Now please remember, whenever I am writing the formula of a compound or a molecule, if you observe carefully, first one will be having capital letter, then all of them will be small letter. And there will be space. Space should be given. When I am writing it in terms of words, there should be space. Sodium hydroxide. Because this is one element, this is another category of element which are coming together to form the compound. Rohan, when I am writing calcium hydroxide, now all of you have written, but Shankar, whatever he has written is correct. I will come to that. When talking about calcium, it will have plus 2. Hydroxide, we know, minus 1. Same thing. Now cross multiply. Right? So therefore, CaOH. Now observe carefully. If I write OH2 like this, what it indicates? only hydrogen has become twice, not O. That means only hydrogen, which is not true. It is the whole OH has been multiplied by 2. So therefore, I should mention it in terms of bracket. I should take the help of the bracket. Okay? So that's where I have the calcium hydroxide. Whenever two elements are present, I should use the bracket. Say for example, I have calcium chloride. Fine. So capital, small letter, and there is a space. Calcium chloride. That means I am talking about calcium and I am talking about chloride. Cl minus. Chloride. Okay. So therefore, if I am using the formula, multiplied by 2 multiplied by 1. So therefore, CaCl2. Here there is no requirement of bracket because only chlorine is there. As a single element, chlorine is there. So no need of bracket. But here, since more than one elements are involved, I have to use the bracket. Shubhangi, that's what I was telling. No requirement of using the bracket here because there is a single element. But if I don't use the bracket over here, it looks like calcium is 1, hydrogen is 2. That is not the reality. OH is 2. Therefore, I have to use the bracket because two different elements are present. But here, only one element. So, directly I can write it as CaCl2. No requirement of the brackets. All of you have understood? Fine. So, that's where we should write. And always this number should be subscript. Whenever you are writing the formula in chemistry, always that number should be subscript. Okay? Fine? Any doubt? So that's where sodium hydroxide, I have written the formula. Now, I want to find out the molar mass of sodium hydroxide because question here is calculate the molar mass for sodium hydroxide. Right? So first thing I should write the okay Shankar. Okay, fine. Okay? So first thing I should write the formula. So that is sodium hydroxide. I should write the formula. Okay? Now, once I have written the formula, now I know which are those elements present in this compound. It's a compound. We call it as molecule also, no doubt. But it's actually a compound, NaOH. Right? Because different elements are involved in forming this molecule. So therefore we can call it as a compound. Now when I am calculating the molar mass, first I should know atomic mass of sodium plus atomic mass of oxygen plus atomic mass of hydrogen. So that's what we have the elements. So we have to add atomic mass of all these elements, then we are going to get the molar mass of sodium hydroxide. So therefore, please students remember that once your classification of element topic is done, try to remember up to at least 35 elements. Try to remember. More than that, it will be nice. But otherwise, at least up to 35 elements we should know. Rohan, no. 11 is atomic number. We should take the atomic mass of sodium, not the atomic number. So don't get confused. Atomic numbers are different. Atomic masses are different. Now I am talking about molar mass. So that means I should take the atomic mass, not the atomic number. Yes, now you are right. So atomic mass of sodium is 23. Atomic mass of oxygen is 60. Atomic mass of hydrogen is 1. All of you will agree? So that means finally I am going to get the answer as 40. Right? So now I can write it as 40 gram. I can write it as 40 gram. So that's where I have the atomic mass of sodium 23. Atomic number is 11, no doubt. Atomic mass of oxygen is 16. Atomic number is 8, no doubt. Atomic mass of hydrogen is 1. Atomic number is also 1. Okay, so that's where hydrogen is the only one which is having atomic mass and atomic number same, because it does not have the neutron. Anyway, will not go in detail. All these things you are going to study in atomic structure and in your chemical classification of elements. So no need to worry. Fine. So that's where we have atomic mass of sodium, atomic mass of oxygen and atomic mass of hydrogen. So the answer is, okay Anju, I will explain. So therefore the answer is 40 gram. Fine. So here if I see the given compound was sodium hydroxide. Now I have to apply, I have to find out the molar mass of this particular compound. So how to do that one? First thing I should write the formula. If they have given the formula in question, no need to worry. Otherwise, first thing I should write the formula. Now we know that we have sodium, oxygen and hydrogen. So therefore, atomic mass of sodium, that is 23, plus atomic mass of oxygen, that is 16, plus atomic mass of hydrogen, that is 1. I have to add all these things because they are present in this particular compound. So if I add all these values, I am going to get the 40 gram. Right? So don't take the help of atomic number. Atomic number we should not consider since we are talking about molar mass. So we have to take the atomic mass. So sodium atomic mass is 23. Okay? Atomic number is 11. Oxygen atomic mass is 16. Atomic number is 8. Atomic mass of hydrogen is 1. Atomic number is also 1. That's where hydrogen is the exceptional case, because hydrogen does not have the neutron. But anyway, so that's where we have the atomic mass of these three elements. I have added here and I have got the 40 gram as the molar mass of sodium hydroxide. All of you have understood? So to calculate the molar mass of any compound, what and all is required? First we should know what is the formula of that particular given compound. Right? So that is very important. Second thing you should know, what will be the atomic mass of those elements present in those compounds. So therefore I told, once your classification of element topic is done, at least you should know up to 40 elements, 35 elements. If more than that element, if you know, that will be nice. Otherwise, minimum 35 element at least you should be knowing with their atomic number and with their atomic mass, especially atomic number. Because in most of the case, atomic mass, when they will go with higher elements, they will give. Okay? Even atomic number, if higher elements are there, in question itself, they will give. Okay? Therefore, minimum 35 to 40 element, up to that element, you should know. Okay? So, shall we move to the next one? I will give another one. You can solve it. Calculate the, all of you can write it down. Calculate the molar mass. Calculate the molar mass of glucose. Calculate the molar mass of glucose. Can any one of you Same method. First you should write the formula. Purposefully I have not written the formula. You can find out the mass of the molar mass of the glucose. First you should write the formula. Shall I write the formula, or any one of you know what is the formula for glucose? Can you write it? Yes. Yes. Andani. Yes, it is C6. No need of this one. Directly you can write C6H12O6. So this is the molecular formula. Yes, you are absolutely right. Okay, molecular formula of glucose. Okay, so that means we have 6 carbon, 12 hydrogen and 6 oxygen. Right? Yes, C6H12O6. Yes, Rohan, absolutely correct. Very good. It is 180 gram. Absolutely correct. Now, 6 into atomic mass of carbon, because we have 6, plus 12 into atomic mass of hydrogen, because we have 12 hydrogen, plus 6 into atomic mass of oxygen. Right? Absolutely correct. It should be 180. So 6 into atomic mass of carbon is 12. Right? Atomic mass of carbon is 12. Atomic number is 6 for carbon, but atomic mass is 12. Now 12 into atomic mass of hydrogen, that is 1, plus 6 into atomic mass of oxygen, that is 60. Right? That is 60. If you calculate for all these things, you will get the answer. 6 2s are 12. So 72 plus 12 plus 96. Right? So now if I add 96, 72 and 12. Yes, that's where we are going to get the answer as 180 gram. Right? That's where we are going to get the answer as 180 gram. Yes, Stefan, 96 I wrote. Thank you. So that's where we have the molecular mass, molar mass of glucose, 180 gram. Very good. Fine. All of you have understood? Okay. Shall we move to the next one? Means example I will not give. You can practice. Okay. We'll move to the next concept. Fine. Now we have another word which is called as formula mass. Even in your textbook it is there. We have another word called as formula mass. Molar mass, formula mass. The way of calculating both are same. Whether I am talking about formula mass or molar mass, both will be calculated in the same pattern. Methodally ಏನು change ಇಲ್ಲ. It will be of same pattern. Okay? But why in that case, why it is called as formula mass? It is applicable majorly for ionic compound. It is majorly applicable for ionic compounds. So that's where it is majorly applicable. Anyway, in detail for ionic compound and all, I will not discuss. You are going to discuss that one in chemical bonding. But briefly here I will tell. Okay? So ionic compounds are those which are made up of ions. Okay? So or which are having ionic bond in their structure. Which will be having ionic bond in their structure. Fine. See, for example, I have sodium chloride. I have sodium chloride, which is solid because it's a crystal one, right? Uppu, table salt, that is nothing but sodium chloride, which will be solid at room temperature. But when I will add it to the water, now no more it will be sodium chloride, NaCl. It will get dissociated as Na plus Cl minus. It will get dissociated as Na plus Cl minus. That's where sodium chloride together, it will be solid, okay, at room temperature. When I am adding it to the water, now they are getting dissociated as Na plus Cl minus. That's what AQ stands for. AQ means aqueous. Okay. But Rohan, whenever I am writing NaCl, I have to write it as NaCl only. I should not mention it as Na plus Cl minus. It will be wrong. Because equal positive negative charges are there. When they are together, there is no net charge. So therefore, it's a neutral molecule. Okay? It's a neutral molecule. But when I am adding it to the water, they are getting dissociated. Fine? Now, if I take glucose, just now we have mentioned glucose, which will be solid in nature. When I will add it to the water, it will get dissolved. All of you might have observed, whenever sugar is added, it is a similar compound like glucose only. Whenever sugar is added to the water, whether it will get dissolved or it will not dissolve, what will happen? It will get dissolved. Same way, glucose also get dissolved, but the only thing here is, there is no dissociation. Here also it is C6H12O6, here also it is C6H12O6 only. When it is in crystal form or whether it is in aqueous form. In both the case, formula is same. But here, in solid state, it is having NaCl, but here it is becoming Na plus Cl minus. So therefore, for this type of compound, we will coin the word called as formula mass. We will use the word called as formula mass, because if I go with aqueous condition, I cannot have NaCl. It is Na plus Cl minus. So therefore, I will take the help of formula. I will take the help of molecular formula and I will calculate the mass. Method is same. How to calculate NaCl molar mass? We have to take 23, that is atomic mass of sodium, and 35.5, that is the atomic mass of chlorine. So we are going to get the molar mass of NaCl, which can be called as formula mass, because NaCl, since it is an ionic compound, it will get dissociated under aqueous condition. Fine? It will not remain as NaCl. All of you have understood? Any doubt in this? Okay? So shall I move to the next one? Now whatever next one I will be telling, that is once again very, very important. Another V, extra V I am adding. Okay? So whatever next I will be telling, that is very, very important. Okay? So that is loss of chemical combination. Loss of chemical combinations. Okay? Now, when I am talking about loss of chemical combination, if you observe it carefully, I am using the word plural, loss, L-A-W-S. I am not talking about one law. I am talking about different law. Right? So therefore it is called as laws of chemical combination. From this, anyone they can ask in your exam. All the laws are important. Anyone they have asked many times in the examination. Fine. So in that, first one, law of conservation of mass. That is the first law. Okay, which was coined by Anton Lavoisier. Okay, so he is the one who coined this particular word. Anton Lavoisier. Okay, law of conservation of mass. Now we here have the word conservation. Mass we know, law we know. What do you mean by law and what do you mean by mass? So what do you mean by this conservation? Conservation means without change. It will remain as it is. It will not get disturbed. Say for example, if you go to some of the area, Banerghatta National Park, it's a conserved area where we cannot go with killing the animals and all. We cannot roam here and there easily. So that's where we have conserved area. Right? So same logic is applicable here. Law of conservation of mass. That means this particular thing based on the title only we can tell. Yes, here mass will not get changed. It will remain same. Right? ಯಾವುದೇ ಒಂದು ಫಿಲ್ಮ್ ನೋಡಬೇಕಂದ್ರೆ ಟೈಟಲ್ ಮೇಲೆ ಹೇಳ್ಬೋದು, ವೆದರ್ ಇಟ್ ಇಸ್ ಫೈಟಿಂಗ್ ಫಿಲ್ಮ್ ಆರ್ ಲವ್ ಸ್ಟೋರಿ ಆರ್ ವಾಟ್ ಎವರ್ ಇಟ್ ಈಸ್. ಎನಿವೆ ಲವ್ ಸ್ಟೋರಿ ವಿಲ್ ಬಿ ಕಾಮನ್, along with that more fighting or less fighting. So based on that we can decide, right? Same way, based on the title we can tell what it might be dealing with, right? So here talks about there is no change in the mass. Which mass? Whose mass? That is the question now, right? So now we can define that this law states that matter cannot be created or nor destroyed. So that's where we have matters cannot be created nor destroyed. That's what it tells. Okay, that's what it tells, this particular law. That means yes, Ignesh, very good. So that means conservation of mass. Whose mass we were talking about? We were talking about the matters. Because chemistry is nothing but study about the matters, right? So therefore here conservation of mass is related to matter. Okay, so that's where matters cannot be created nor destroyed. That means if I have sodium as one of the element, I have sodium. What is the mass? Mass is 23 gram. If I take in terms of mole, okay, so I have the 23 gram. No, Stephen, that's what I mean to tell. That is different story. I will come to that. So sodium 23 gram. Now if I change this 23 gram to 20 gram, now it is no more sodium. So what I mean to tell here is sodium atomic mass will remain as 23 gram. Or in some of the elements, if I take average atomic mass, if I neglect that, if I take it as an individual element, then it will be, mass will be constant. That's what I was telling. Mass will be constant. Okay, fine. So that's where we have the law of conservation of mass, where it tells that matter, that means sodium, we cannot create by our own. Carbon we cannot create by our own, right? So therefore it cannot be created, it cannot be destroyed. It cannot be created, it cannot be destroyed. Now, when I am talking about nuclear fusion reaction or fission reaction, that is a different story. Okay, that is a different story. Don't worry about all those things. But at this moment, we cannot create a matter or we cannot destroy the matter. I am talking about a regular chemical process. Okay, during that time, we cannot create any element. Got my point? Sodium cannot be created, a new element cannot be entered into a reaction. So that's where we have the law of conservation of mass. All of you have understood? Any doubt? Okay? We will move to the next one then. Okay? So next one tells about law of definite proportion. Law of definite proportion. Right? So what do you mean by proportion? Proportion means I can tell ratio or like that I can tell proportion. Definite, that means it should be same. It cannot be different. Right? Say for example, if I take water, H2O, a simple and common molecule, water. If I see here, we have the hydrogen in 2 and we have the oxygen in 1, 2:1 ratio. So what I mean to tell here is, whenever hydrogen and oxygen present in 2:1 ratio, they will give the water molecule. They will give the water molecule. But if I take H2O2, a hydrogen peroxide, if I take H2O2, hydrogen peroxide, now hydrogen and oxygen ratio is 2:2. Hydrogen oxygen ratio is 2:2. So now it is a different molecule. Water is different, hydrogen peroxide is different. So what I mean to tell here is, if I observe these examples, all the compounds in the nature, whatever compounds are present, they have definite proportion of elements. They have the definite proportion of elements by weight. They have the definite proportion of elements by weight. Yagnesh is writing, a chemical compound always contains same element combined together in the same proportion by mass. Yes, that's what we can tell. Yes, absolutely correct. So now we can define that this law states that compounds in the nature, compounds in the nature will have definite proportion of elements. Definite proportion of elements. Definite proportion of elements by weight or by mass. Anything is fine. Or by mass. Okay, that's where we have the law of definite proportion. Compounds in the nature will have definite proportion of elements by weight. So what I mean to tell her is, if I take water in Mysore, it will be H2O only. If I take water in USA, it has to be H2O only. It cannot be different. Right? If I take it to the moon, it will be H2O only. It cannot be different. So that's what law of definite proportion talks about. That's where we have the law of definite proportion. Any doubts in this? Any doubt? Okay, another word we can use is law of definite combination. That one also we can tell. Combination or composition, anything is fine. Law of definite combination, or we can use the word, instead of combination we can use the word composition. Anything is fine. Law of definite combination or law of definite composition. Fine. So that's where we have law of definite proportion. Okay. So which was coined by Joseph Proust. It was coined by Joseph Proust. Okay now. So this particular law was coined by Joseph Proust. Okay. Still, we have many more laws. Next one. Now this is with respect to law of multiple proportion. Law of multiple proportion. This is related to law of multiple proportion. Law of multiple proportion. Hagandre. In earlier case it was definite proportion. Here it is related to multiple proportion. So proportion is that, but another word extra added here is multiple. That means more than one something should be there. More than one something should be there. So that's where I will take the example of previous one. If I take water and hydrogen peroxide. If I take water and hydrogen peroxide, what is that common in these two? Can any one of you? What is that common in these two? Water and hydrogen peroxide. What is that common you can observe? Sir, ಬೆಳಗ್ಗೆ 8 ಗಂಟೆಗೆ ಬಂದು ಪಾಠ ಮಾಡ್ತೀರಾ, ನಮಗೆ ನಿದ್ರೆನೂ ಸರಿಯಾಗಿ ಆಗಿರಲ್ಲ, ಅದರ ಮೇಲಿಂದ ಕ್ವಶನ್ ಕೇಳ್ತೀರಾ? No, simply I was kidding. Okay. Anju, Andani, Ullas, Shubhangi, all of you have written hydrogen. Okay, very good. Right? So both of them they are having hydrogen, no doubt, H2. And even Andani is also right. Both of them having common elements like hydrogen and oxygen. All of you are right in your own way. Okay, so all of them they are having H2 common, no doubt. But even Andani is also right. Both of them they are having hydrogen and oxygen. Right? So now I can tell that these two elements are having same type of elements. So that's where this law applicable, law of multiple proportion. It tells that when two elements are involved in forming more than one compound, listen to me carefully, anyway I will be writing that one. When two elements, Yagnesh, very good, you are so fast in typing. Oh, very good. So it tells that multiple proportion tells that when two elements are involved in forming more than one compound, in this case that which is that more than one compound, water and hydrogen peroxide. Water and hydrogen peroxide. Fine. So in that case, one element, any one element which is combining with the constant mass of another element will form a simple whole number ratio. Yes, sir? Confuse agoytu, sir. First I will write it down. Don't worry. When this law states that when two different elements are forming more than one compound, okay, mass of element combining with constant mass of another element, will have or will have simple whole number ratio. Will have simple whole number ratio. Okay, ratio now. Okay, it should be ratio. All of you have understood? All of you can see the board, right? 1 minute. Okay, fine. So that's where we have a definition. When two different elements are forming more than one compound, mass of element combining with the constant mass of another element will have simple whole number ratio. See here, example. Now, which is that element which is having constant mass? That is H2, as you people told. That is H2. Which is that element which is variable? That is oxygen. Right? So, this oxygen is combining with two hydrogen. Here, these two oxygen are combining with this hydrogen, two hydrogen. Right? So, hydrogen is constant. That means, I am talking about with constant mass, that is hydrogen in this example. And which will form the simple whole number ratio is oxygen. So here it is 1 oxygen, here it is 2 oxygen. Therefore, the ratio is 1:2. The ratio is 1:2. If I take this one as the example. Sir, only in this? No, we can take any example. Carbon monoxide and carbon dioxide. Alright? So where carbon and oxygens, they are involved in the formation of the compound. Yes, Shankar, I will repeat. Where carbon and oxygen, they are involved in forming the compound. Now, which is that constant mass? Carbon. Which is that variable? Oxygen. So that is 1 and 2 oxygen. So the ratio is 1:2. Ratio is 1:2. Right? So therefore, very important point here is two different elements, not more than two. We should take two different elements. That means hydrogen and oxygen here, carbon and oxygen here. Right? So now I will repeat. Now this particular law states that when two different elements, sir, board can't be properly. Okay. I will change the chalk piece. I agree, Appa. Okay. So, when two elements, when two different elements, okay. So, when two different elements, now you can see, when two different elements are forming on this one I am writing, are forming more than one compound. When two different elements are forming more than one compound. Okay, more than one compound. More than one compound. Fine. Now it's visible. Okay, fine. So I will write it there also. When two different elements are forming more than one compound, that means in this case, when I take water and hydrogen peroxide, which are two different elements, hydrogen and oxygen. If I take carbon monoxide and carbon dioxide, which are those two elements, carbon and oxygen. Fine. So that's where I have the statement. When two different elements are forming more than one compound. Next continuation. Mass of elements combining with constant mass of another element. Constant mass of another element. I will stop here. Means I will continue. Mass of element combining with constant mass of another element. So which is the constant mass here? That is hydrogen. Which is the constant mass here? That is these two carbon. So that's where we have mass of element combined with constant mass of another element. So constant mass of another element is hydrogen and carbon, which is another element which is combining oxygen in both the cases. Will have a simple whole number. Will have simple whole number ratio. Okay, so that means they will not form in fractions and cluster. They will form simple whole number ratio. So that's where in this case if I take water and hydrogen peroxide, which is that variable element? Oxygen. So the ratio between these two oxygen is 1:2. In carbon monoxide and carbon dioxide, which is that variable? That is carbon and oxygen, where oxygen is variable. So in carbon monoxide 1 oxygen, in carbon dioxide 2 oxygen. So what is that ratio? 1:2. There is no fractions. That's where it is forming whole number ratio. So here important word here is when two elements. You cannot take glucose C6H12O6 where 3 elements are formed. It's difficult. If I take 2 different elements, then it will be appropriate. When 2 elements are forming more than one compound, right? So that's where this law is applicable. Okay, fine. So when 2 different elements are forming more than one compound, mass of one element which combines with the constant mass of another element will form a whole number ratio. Okay, so that's where we have the law of multiple proportion. Any doubts? Any doubt in this? Say for example, what is the mass of oxygen here? 16 gram. What is the mass of oxygen here? 32 gram. So 16:32. That is nothing but 1:2. Same logic is applicable here also. So that's where we are talking about mass. Okay. Now you people were able to see the board? No problem, right? Board is visible now. What I will do is next time I will write it with larger this one. I had written with small this one. I will write it in bigger words and all. I will write it in bigger size. Okay. But now can you see the board? All of you? Okay, fine. Anyway, I will stop here. Okay. Now, since tomorrow you have a holiday because it is a Sunday, now what you can do is whatever concept we have discussed, try to go through the check sheets, whatever you have got, and go through the textbooks also, NCERT textbook, and whenever exercise problem is there or question is there, try to practice that related to the concept which we have discussed. Got my point? So you can practice those things, and Monday once again we will meet. Okay? Any doubts in today's concept? Okay. Thank you, Pa. Okay? Enjoy Sunday. Enjoy the holiday. Okay. Bye. Take care. Thank you.